Okay, so now let's take a look at looping part 1. Okay, so I'm just going to get the door. All right, so we just saw in that little demo how it's easy to make people do what you want if you can control them, just like in the last unit when we controlled them. And computer programs are really good at doing the same thing over and over again. That's one of their strengths, is doing things over and over again. So a loop allows you to repeat instructions or code over and over again. They're another control structure that changes the flow of your program, just like the if statements did. And it allows you to execute code multiple times, basically as many times as you, the programmer, decide you want it to execute. Now, we've seen this structure before. We saw it way back when we did flowcharts. It was still a decision, but based on the outcome of that decision, if it was true, it would do something and then go back and check it again. And if it was true, it would just keep doing it over and over again in a loop. Only when it was false would it go on and do something else. So we can now set this up in our code if we can write this thing called a loop statement. Okay? Now, in a lot of ways, the loop is very identical to the conditional statement. It evaluates to true or false, just like our demo today was either true or false. Inside the loop, we'll have code that will cause a change that might affect the outcome of the test, just like a conditional statement. Okay? Only when it's false will the loop stop executing. As long as it's true, it keeps running the loop. Now, there's two ways loops can occur. We'll look at the first way in part 1 and the second way in part 2. But the first was called an event control loop, which basically means the loop runs based on the outcome of an event. For example, if you were reading data out of a file, like say you had high scores stored in a data file, it would keep reading them as long as there was data in the file, and then it would stop. So the event of the end of the file would signal the end of the loop. And then the second one is basically like we saw today, a loop that runs on a count. If you say, I want it to run 10 times, it runs 10 times, or 100 times, it runs 100 times. Okay, so basically the loop is asking questions, just like the if statement. Are you at the end of the file? No. Okay, read another piece of the file. Are you at the end of the file? No. And it would keep doing it. When it answers the question yes, it's at the end of the file, it will leave the loop. This is very similar to the if statement, except in the if statement, it just would do the inside part once and then move on. Whereas with a loop, it does it repeated numbers of times. And that's also the way it's going to work with counting, right? Is x greater than or equal to 5? Okay, well, I could just keep adding and stuff like that on the loop as it moves on. Actually, that should say less than or equal to 5, okay? Etc. So that's the basic structure. The way we're going to work this in the first loop we're going to write is with what's called the while loop. So the key word that we're going to write with is the word while, okay? Now, the while loop is an event control loop, and it comes in two different formats. One is the first one is the one you're going to find the most common, and then the second one is a little more of a rare format. But basically, when you want to test your loop at the top of the loop, or when you want to test your loop at the bottom of the loop. And that'll make a little more sense once we start coding it. Now, just like if statements, loops evaluate to true or false. And just like if statements, if you want to get fancy, you can also combine your logic using the and the or, which some of you now realize is useful, especially in some of the programs like in the last unit's slot machine program. That was really useful, if you got to that one, to know that little trick. It made your life a lot easier. Okay? So we're not going to do this, but I'm just going to show you this code. We will be doing an example. Okay? So the way it works is like the if statement. It uses curly brackets and round brackets. So if you didn't see this word right here, while, you'd think it was an if statement, right? If number is less than 5, do this. The only difference is instead of the word if, we put the word while. Now, how that changes it is, it still works like an if statement, but it stays inside this code. It doesn't leave the code. It only leaves it when it's false. So what it does is it creates a loop inside the block between the two curly brackets. So what would happen here is it'd say, okay, number is 0. So while number is less than 5, well, sure, 0 is less than 5. So it would show the number in a message box and then add 1 to the number. So now it's 1. Then it would go back to the top of the loop, and is 1 less than 5? Yes. So it would do the code again. Okay? So it would say 0, 1, 2, 3, 4, 5. You'd have 6 message boxes come up in a row based on that loop. Okay? Now, once it got to 5, or pardon me, got to 6, it would go up to the top of the loop and it'll say, well, 6 is not less than or equal to 5. So it would fail the test and it would leave the loop, just like it would have left an if statement. And the code would get skipped that was inside. So think of a while loop just like an if statement, except it keeps repeating itself inside while it's true. And it's kind of the way we talk naturally, right? You'd say, hey, while I don't have any homework, I'm just going to relax tonight, right? It sort of creates this sort of thing that keeps going while something's true. So while loops begin with the keyword while. You'll notice it appears in blue. It also has round braces, and it also has curly braces, just like an if statement. Okay? So it's going to be an easy transition if you've understood if statements to transition to the while loop. Okay? But it gets a little more powerful into what it can do. Now, another thing I forgot to mention, just like an if statement, the code inside the curly brackets is indented. That's done so that you can see that these two lines of code are controlled by the loop, because it's a control structure. So those two lines are controlled by the loop itself. Okay? Now, although I don't recommend it, just like an if statement, if the line of code inside the brackets is actually only one line of code, you don't need the curly brackets. They can be omitted. Okay? Just like with the if statement, you can do that. Now, there is a variation you can do on the while loop that's less common. As a matter of fact, you may not even need to write this year at all. There's one problem coming up in the unit that may require this, but you don't actually have to use it to get it done. And this variation of the while loop adds another keyword. And the keyword is the keyword do, which is exactly what it says it means. It just says do this code. Okay? But then with this while loop, you test it at the bottom of the loop. Okay? So here's what it looks like. What happens here is the while part's now at the bottom, not at the top. It's at the bottom. So at the top, you put the word do, which basically just says do this code. And then at the bottom of the loop, that's where it tests it. Now there's also one strange quirk about the do while loop, this one you see here, is at the end of it, it has a semicolon. Normally you don't put semicolons with loops or if statements. You just don't. But this is an exception. Now, as I said before, this loop is really rare. As a matter of fact, if you don't learn this loop, you probably get by just fine. You won't need to worry about it. But know it exists. And the only reason you'd ever want to write this type of loop is, as it says right here, because it tests at the bottom of the loop, the stuff that happens inside the loop will happen once no matter what. Because there's no control here. It just says do this line. Now, it's possible that if I start this at 10, it'll still add 1 to it, but then it'll test false down here. Oh, okay. So the code will run once and then fail the test. Now, if you go back to the other loop that we were looking at here, if I start this at 10, it'll never enter the loop, right? Like it'll fail right away, and the stuff inside the loop will never run, just like an if statement. So this other while loop has the benefit of at least running one time before it's done. Okay? It's quirky though. It's a quirky version of the loop. So you know it exists in your notes. You can access it if you need to. As I said before, you won't need to in this unit, but you may want to as you program it because it has a bit of an advantage in some ways. Okay, now watch out. Loops can be infinite, which means you've miscoded it and nothing will stop it. It'll run forever. Okay? This is called an infinite loop. Here's an example of one. There's no syntax error in this code. In other words, you won't get a bug when you run this code. But what's wrong with it? Let's take a look at the code. So it says, okay, I'm going to start a variable off at -1. And I'm going to say, well, that number is less than 0. Well, -1 is less than 0, right? But then what do I do to the number? I subtract 1. So what does it become? Does it? -1 minus 1 is -2. Is -2 less than 0? Yeah. Then what does it do to it? Makes it -3. Then -4. Is it ever going to fail this test? No. It will infinitely run. Now what happens when you do this, when you try and run this on a computer program, is eventually you run out of memory. Because that variable just gets smaller and smaller. It becomes -5, -500, -5,000, -50,000. eventually, integer reaches its maximum. We learned that back in the variables unit, that there is a maximum amount that integer can be. Not like in math where it can go to infinity, which is not a real thing. But in the computer, it is a real thing. It's like, well, I can only go so much as a negative number. And then it crashes. It'll give you an error saying it runs out of memory. Okay? Maybe, actually, just for 1 second, I just want to show you that because I can guarantee that at least one of you that's going to happen to, you're going to run into an infinite loop, and you got to know how to stop that, or your life as a programmer will not go well. Okay, so hang on 1 sec. Let me just let this start. And while that's starting up, I'll just go over some more of this content here. Which loop is better, all right? Well, to be honest, it's the first one is generally the better loop to use because it's easier to code. But there are times when you do want to use that do-while loop. Again, it's if you're comfortable programming it. But the fact is, a test that runs at the bottom of the loop in some problems is more efficient. This is something I would more focus on in my grade 11 course, sort of the efficiency of the way you write your code. But in general, you choose the one that's appropriate for your program, and most times it's just the one called while. Now there's another loop we're going to learn in part 2, okay? We're going to learn a second type of loop, but for the first 2 problems in this unit, you're not going to worry about it. Okay, that's it for looping. But in order to attack the 2 problems I'm going to present to you guys, I want to show you a little bit more code that might help. Because at this point, you're not beginners anymore. So I like to sometimes toss in a little more code as we move along in our programming. So the first thing I want to do is just some shortcuts. These are not necessary. So if you're still struggling with coding at this point, then these are just extras that they're just like icing on the cake. They're not necessary things. But for some of you who are doing well in all this stuff and are understanding it completely, this might actually make your coding life a lot shorter. Okay? So one example is you can actually create multiple variables on one line of code. We've done variables before, but you can actually do this. Int x, comma y, comma z. That makes 3 variables in one line. You don't have to say int x, semicolon, int y, semicolon. You can even assign them values. Double a equals 0, comma b equals 0, comma whatever. As long as you separate them with commas, you can do this. I'm not saying you should do this. I'm just saying you can do this. Okay? It's shorthand. Now, here's another piece of shorthand. Because we are always adding 1 to variables, it's very common in code to say x equals x plus 1. C# made shorthand for that. And it's this, x plus plus. This right here means x equals x plus 1. Similarly, if you go x minus minus, it means the same as x equals x minus 1. You do not have to use that code. This and this do the exact same thing. It's just shorthand. It's code shorthand. Just like in math, we use shorthand. Instead of writing 2.x to mean 2 times x, we just write 2x to mean 2 times x. So it's laziness from the programmer standpoint in this case. This also, by the way, is the really bad joke why the programming language C++ was called what it was. Because C++ evolved from the programming language C. So in other words, it's the language C plus one other thing. Now, if you really want to get shorthand, you can also get to this one. Now, this one I may not recommend for anybody in here unless you're really feeling confident. You can actually do this. X plus equals 10 means the same as x equals x plus 10. And you can put whatever you want there. So that just is shorthand for meaning x equals x plus, or x equals x minus, or x equals x times, or x equals x divide. At this point, though, your code is getting a little more cryptic, a little more difficult to understand. But it's less typing to do it this way. So it's really shorthand for lazy coders who just want to sort of write less. And by write, I mean type. Okay? So this is extra. Nobody needs to do this in their code unless you feel confident doing it. All right. This one is a neat one that I don't know if you guys have heard of before. It's not actually a computer science thing. So it's a division thing. Okay? So if I take the number 25, okay, and I'm going to divide it by 3. Okay? Now, you guys probably haven't done long division like this in a long time. But remember when you first learned it? How did you do this problem? You'd go, okay, 3 goes into 25 how many times? Is it 7? Is it 5? Wow. I mean, come on, you guys. How many times does 3 go into 25?
8.
8. What's the answer? 3 times 8 is? Really? 24.
8 less 1.
And do you guys remember this? Remainder 1. Remember remainders? Do you remember remainders? Let's try another one. Real quick. 13 divided by 5. What's the answer? 2. No points. Remainder 3. Do you guys remember remainders? Before you learned about decimals, you worked with remainders. Right? Remainders are actually a useful value. You guys are used to going all into decimals and stuff like that, and your little calculators give you decimals. But there are times that remainders are actually useful to you. Tons of times, actually. Sure, I'll give you an example right now. What if I gave you this number? 5, 8, 7. And I asked you to mathematically separate the digits, 5, 8, and 7. How would you do that? Well, you could probably figure out how you get the 5, right? How would you get the 5 mathematically? I could divide it by 100, right? The answer is 5, right? And then some remainder or some decimal. What's the remainder? Now, if I take the number 87 and I just want the 8, what would I divide it by? No. 10. I get 8. What's the remainder? In other words, gives me the 3 digits. Okay? Let's think of another one. Let's say you were working in a shipping company and you shipped out dooflingies, their little product. And you have 3 boxes. You have the box that can hold large dooflingies, and it can hold 100 dooflingies at a time. And then let's just make it 2 boxes. You have a small box that holds 10. No, let's make it 20 dooflingies. So you can ship out dooflingies in these 2 sizes of boxes. So someone makes an order for dooflingies. They order 737 dooflingies. How many boxes are you going to need of each one? You don't know? I know. I can divide this by the number of large boxes, which is 100. And I get 7, remainder 37. So in other words, I'll need 7 large boxes. I take that 37 and I divide it by the number of small boxes, which holds 20. And I get 1, remainder 17. So I'd need 2 of these. One holds 20 and the other holds 17. And I'm done. But in this case, again, the division allows me to get the remainder because I can use it usefully. So if I go back to where I started with this idea of remainders is actually something you can calculate. Your math teachers probably don't teach you this, but the term for the remainder is what's called the modulus division. Okay? In other words, 25 modulus, and I'll just shorten it to mod, because that sounds cooler, 3 equals 1. Now, 25 divided by 3 gives you 8, right? 25 divided by 3 gives you 8. But 25 modulus 3 gives you 1. 13 modulus 5 gives me 2. So this is how it works. In computer science, specifically C#, they picked a symbol to do this. And the symbol is this one. what we'd call the percent symbol, they use for modulus division. And here I'll show you what I mean by this. So here this is again, sorry? They just had to pick something. They didn't want to use the slash because that's for regular division. So here you can see 20 mod 7. What is the answer to that? Well, 20 divided by 7 is 2, remainder 6. So notice the output is 6. Okay, it's a weird quirk. But this idea of modulus is a little more mathy, but it's something simple you can put in your code if you require this. Okay, another little quirk. Sometimes users, put a lot of extra spaces into stuff. They don't know how to use your program. It says enter the word, and they put a bunch of spaces at the beginning and maybe a bunch of spaces at the end, and it messes up your code completely. So you know what? There's a feature built into this called trim that automatically trims off any spaces at the front or back of something. Again, this might be something useful when you get to something like your final project. If you have people entering names for, say, high scores, you may want to trim off the extra spaces. So know this exists. If you need it, there's an example here in the code that shows you. So for example, notice how I entered this with a bunch of spaces at the front and the beginning, but then I trim it, and then I output it, and when I output it, all those extra spaces were trimmed away. Okay? It's just another little bonus feature. Now, this one you will need to use in the programming problems that are coming up in this unit. It's something called a list box. It's a little different than a text box because it allows you to list things like this. As well as you list them, if they get long enough, it'll automatically add a little scroll bar to it. We're going to do this in the example today. So the list box allows you to enter a giant list of things. Okay? Now in here I show examples of the code, how you can add items to a list box and access items in the list box, select items, etc. But we're going to do this in the example today as well. So I just wanted to show you the code there, how to do this, and then we'll jump forward. Identical to the list box is the thing called the combo box. The only difference is it looks different because it saves space by hiding the list in a little drop-down thing. But it works exactly the same as the list box, the combo box. Okay, let's do an example. Some of you guys are sleeping. Here's what I need you guys to build. It's a form, but take notes. There's two important things here. This is not a text box. This is a combo box. This is not a text box. This is a list box. Third thing that's important to note, when you get around to naming these things, if you're going to use my names, that is an L, not a 1. That is LST for list box. You can't use a 1. So that's L, I'm sorry, but it just looks like a 1, but that's LST, list box numbers. Okay, let's get to work. Let's build this. We don't have a lot of code, but we have some code to code with this. Okay, so here now we have our design. The first thing we're going to code is something we saw in the last unit, form load. To get to that code, find an empty spot on your form, usually down near a bottom corner would be a good place, and double-click your form. And it should say form load. Now, if you named your form, like I did, it'll give the name of the form. So here it says FRM example underscore load. But if you didn't name your form, it'll just say form1 underscore load. Okay? So this is the code that basically says, when the program first launches, before you see anything, what should I do? So I'm going to tell it what to do. What I'm going to do is change the thing called CBO values. That's my combo box. And here's how you add things into a combo box. It's a two-step process. You say combo values dot items dot add. So it's, and then you don't put an equal sign. You put a round bracket, and inside the round brackets you put what you want to add. So I'm going to add a 10. Okay, so that's the line of code. Let me zoom in on it so you guys can see. That's okay. So that's the line of code you want to put in there. CBO values dot items. So it's saying, okay, I want to add to the items of this combo box a 10. That's what the code is saying. Now, let's see if it works. I'm going to play this. Nothing looks different, but if you click on that combo box, you'll notice there's a 10 in there now. There was no 10 in there before. So now the code has added a 10 into the combo box. All right, let's repeat that code. I'm going to copy and paste it. You can retype it if you want. And I'm going to put 100 in there. Then I'm going to paste it again. And I'm going to put 1,000 in there. And then 10,000. Okay? So I'm going to add 10, 100, 1,000, 10,000. I'm going to add all those into my combo box. And then test it. I'm going to play it. Notice the combo box hides itself, but when you click on it, there's all the numbers that I just added in there. So that's how it's working, right? It's adding those things into the combo box. Okay? Now, combo boxes also have a text property. So I'm going to change that on the last line. CBO values dot text. So like a text box, I can also do this. Now, there didn't seem to be any text in the combo box until I clicked it. But if I put 10 here as well, like that, and then run it, now you'll notice it starts with a 10 in it, and I can click on it. So it's giving me both features. Whereas if this line wasn't there, I'm just going to delete it for a second. Notice it starts with nothing in the combo box. Okay, so let's put that in for form load. Okay? And this exact code is in the notes as well. You can see here. It says to double click the form and then add that code in there. So it's the exact same code. Okay, we only have one more thing to code, and that's the button. We're going to code the button. Yes? What? I have what? Oh, yeah, sorry. You're right. Dot text equals. Oops. Thank you. There we go. That's what I wanted on the last line, and it doesn't need the brackets. So what that does is it just puts text into the combo box like I had before. Sorry, I thought I had copied and pasted properly, but I guess I didn't. Thank you for that. All right. So now that that's done, let's go back to our design and double-click the Find button. Okay, so now we're going to add some code to the Find button. Okay, now the first thing we're going to do is, since this program might run multiple times, we're now going to use this list box. Now, what this program is going to do, by the way, is it's going to guess a number between 1 and whatever number we chose from our maximum. So it could be 1 in 10, 1 in 100, 1 in 1,000. So it's going to pick a random number between those two numbers, and then it's going to try guessing it randomly, guessing for that number. And in the list box, it's going to show you each guess until it gets it correct. Okay? So it'll tell you how many times it guessed to find the number. So let's go to the code and make that happen. But because this might run multiple times, each time we click Find, we want to clear out the list box from the last time it ran. So here's the code on how to clear out a list box, but it also works for combo boxes. Okay. So I'm going to say LST numbers, that's my list box, dot items, dot clear. But it does have those round brackets on there. Okay? We've seen that a few times with a few pieces of code. Application.exit, use the round brackets. Message box, use the round brackets. And here, this one, where I say clear out the list box, it uses the round brackets. Now don't bother testing that, because it's already cleared out, so we won't see any difference. Okay, now we need some random numbers. So the good old line, random equals new random. Equals new random. And that also random uses round brackets on the second one. So random random equals new random. So now we can start making random numbers. Okay. So now we need a couple variables. We need an integer for the number. And let's start it off at 0. So int number equals 0. Now we need a second variable, so I'm going to use that shorthand. I'm just going to put comma, guess, also equals 0. So there, I made two variables on one line. Number equals 0, comma, guess equals 0. Now I'm going to make a string of text. And it's going to be equal to CBO values. So here I'm going to read the text out of the combo box. Dot text. But I'm going to add one nice little feature. I'm going to say dot text dot trim to trim it off. Now that won't happen, that necessarily they'll have extra spaces in there, but they could. So I'm going to trim away any extra spaces. A little bit of fancy code, why not? Now I need my maximum. The maximum, int maximum equals convert dot to int 32 of that text. This is not unfamiliar code. We've done this before. We've converted the number or the text into a number. Done that. Now we need our actual answer, the thing we're going to be looking for. So int answer equals random dot next, and we'll pick a random number between 1, comma, and our maximum plus 1. We need to do that because the random number generator always misses it by 1, so we have to add 1 to the maximum. You could do plus plus, that's right. Why don't we do that to be super cool? Now, all of this is just some fancy code, a little bit of new stuff, but nowhere in here do we have a loop. And I thought this unit was about looping. Well, it's about looping now. While, okay, number does not equal the answer. So the number is what we're going to be using to guess, and the answer is the right answer. So while they're not the same, we're going to keep guessing. That's what this loop's going to do. It's going to keep guessing and guessing and guessing until they're the same, which means I got it. Okay? Now, as we guess, we're going to keep track of how many times we guessed. So I'm going to take that variable guess and increase it by 1 each time. Any idea how I might do that? I'm going to use the plus plus again. That means, that line of code means guess equals guess plus 1. Now, I need to guess. So I'm going to say number equals random dot next bracket 1 comma max plus 1. Whoops. Now, at this point, I need to change some of the code I had because you guys had a great suggestion that max plus plus would have worked up here. But what's the problem with using it up here? Is now the maximum has increased by 1. Because remember, what that line means is max equals max plus 1. And I don't want to increase the max. I just want 1 more than the max. So I actually need to change this code up here back to plus 1. And that's an important difference. Plus plus means it will go up by 1. If I just add 1 like this, it just means it didn't change maximum. It just went 1 more than the maximum. Okay. So here's what's happened so far. I cleared out the list box. I'm going to create a random numbers. I'm going to keep track of the number and keep track of the guesses. I read in from the text, from the combo box, what the maximum the user wants to guess to. I then convert it to a number and generate a random answer between 1 and that maximum. While those two things are not the same, I make my first guess by increasing the count and then taking a guess right there. So now I should show the user. what I just guessed. So I'm going to go to LST numbers dot items dot add, and I'm going to say first the word guess plus the variable guess. Okay, so there's the guess itself. Okay. Oops. And oops, plus an equal sign plus the number, semicolon. Okay, so I'm going to say, okay, the guess plus the number. So it'll say guess 1, 20, guess 2, 30, right? Like it'll keep showing each guess. Okay, let me pull back a bit so you can see that. And then finally, we're going to add some code on the last line after the loop. Finally, when it's finished guessing and it's finally got the right answer, we're going to display how many guesses that took in our label. LBL display dot text equals it took, I'll put the variable guess, oops, plus guesses to find the number. Now I'm running out of space here. Here's something you can do. When you run out of space, I mean, I'm not running out of space because it can keep scrolling over, but I can always just move to the next line like this. And unless it encounters one of those semicolons, it'll still think this is all on one line of code. I can do that anywhere, right? I can go right here and that's all on one line. And I'll put the answer plus the words between 1 and max. So I'm going to tell my user it took this many guesses to find the number, and there's the number, between 1 and this maximum. So let's see how it actually works. I know some of you are still typing, but watch how it works. So I'm going to say 10. I'm going to use that 10 there. I could pick a different number here. I could go 100. And I click find. Oh, there it is. So the first guess was 27, then 68, then 14, then 95. It shows you the computer guessing, trying to find that that value. Oh, and it took me 88 guesses to find, the number was 32. So it took me 88 guesses to, to find that 32. It was between 1 and 100. And I can do it again. I'll try find. There it took me 2 guesses to find the number 55 between 1 and 100. Let me try 10,000. Oh, that takes a little bit of processing time here. It took 14,736 guesses to find the number, and the number was 8,586, which was between 1 and 10,000. And it shows you all the guesses here. Like it's showing you all 14,000 guesses right here. Crazy. Try it again. Oh, 7,000 guesses. Let me just try with 10 here. Oh, there, it took 14 guesses. The computer's not smart. It doesn't have a system. So notice it guessed 5 here and it guessed 5 here. It has no system for this. It's just randomly guessing the number. But here you see the power of the loop. The loop is causing that code to repeat over and over again. This exact code is in the notes as well. You can see it in the notes. And I know it's getting a little more challenging, but this is the power of looping.